Alright, it looks scary because it has us jumping like 4 chapters ahead, right? We were on 6. Arrays are on 9, but that's just because the book is arranged in a silly order. Arrays should be mentioned a lot earlier than that. On the other hand, talking about classes is awfully important too, so I don't mind that they did it in that order. Next semester when I teach it, though, I may make us skip to chapter 9 before we go back and do chapter 6. All right, so we got a PowerPoint there, chapter 9. It's what we want. All righty. So, what is an array? It's a series of values. If we want to get all technical about it, we'd say it's a series of elements of the same type stored in contiguous memory. Yeah, there, we're getting all fancy. Just means that instead of just sticking one piece of data in a variable, right, like age is equal to 37, we can store a whole bunch of pieces of data in one variable. Well, at least one variable name. Now, we played with classes, right, where we could store a whole bunch of pieces of data in an object. Well, this is different. These are all pieces of data of the same type. These are all phone numbers. So you do not use an array to hold different types of data, like, you know, a first name, a last name, you know, an address and a zip code and a phone number. Instead, they all have to be of the same type. You declare an array of integers, then the only thing you're going to be able to store it are integers. You declare an array of strings, pretty much all you're going to be able to store in it. Now, honestly, you could store integers into strings and then do some parsing on the way back out, right? But they'd still all have to be strings getting in there, and they'd still all be strings on the way back out. Kind of ignore this statement. An array is a limited version of a class. Well, you know, arrays were invented like in 1940, and object-oriented programming came a long time later. However, Java did implement kind of a little tiny wrapper class around arrays, where if you do C++, that does not exist. An array is an array is an array. More like, no, I won't even say more like. So, an array does not store any methods. And an array's data must all be of the same type. So the way you access them is with their variable name followed by what's called a subscript. Every time I say subscript, think square braces, square brackets followed by a number between them. And they start counting at 0. 0-based indexing, just like programmers do for every other kind of lists or strings or anything. So this is the first element in the list at subscript 0. This is the second element of the list at subscript 1. The third element of the list, subscript 2, and so on. We see these numbers increasing sequentially. That kind of hints to us that an awesome way of accessing arrays is with loops, right? Anytime you see a series of numbers, you think to yourself, loops. And there's even a specialized kind of loop syntax that'll let you rip through an array very quickly with a shorter syntax than even writing for I equals 0, I is less than whatever. So if we were going to get the first phone number out of our phone list, we give the name of the variable. We apply the subscript. If we want to get the second one, variable name, subscript 1. And we're just sending it out to print line. Now, for some reason, we haven't even said how to create an array, and we go ahead and we show some source code using arrays. You know, why don't we scroll past that? Why don't we scroll past that? Here we go. To declare an array. Different than it is in C++. Sorry, guys. We'll sit through the next hour and a half. In C++, you put your braces here. In this language, you don't. In this language, you put the braces after the data type. So this says, I need an array of ints, and that's going to be the variable name for it. Now, this doesn't actually create the array itself. It just creates a reference. Just like if you did scanner SC, but you don't do that equals new scanner business, you don't really have a scanner. You just have a reference to a scanner. This is a reference to an array that has not been created yet. The next thing we'll need to do is to create it. If we wanted to create the array at the same time, the syntax would look like this. Equals new int, and there. Now we have room for 100 ints. In this language, every time you create an array, every time you need an array, you either have to have a new keyword like that, or you have to have an initializer list. What's an initializer list? Well, instead of using a new keyword, you use equal, and inside some curly braces, slipped into Python syntax there for a minute, you list some elements like that. Okay, so what Java does is it looks at the initializer list, it goes, oh, I'm going to need 2 elements. And so it substitutes the command new, right? And it puts a 2 in the right place, and then it copies the values in one by one. This is a shortcut for creating an array of 2 doubles. This data has to match this type. Yeah, we could list ints here, right, because ints will store into doubles cleanly. But we couldn't declare this as an int and have these be doubles or strings or anything like that. In this language, once we do that, the values are zeroed out, unlike C++, which tries to make everything as difficult as possible. The data is not zeroed out. So this is using an initializer list, very similar to Python, except in Python we use the square braces to create our list. In this one, to create our array, we do the square braces. Now these aren't constants or anything. We can later on go and change this. If we wanted to, we could set work hours subscript 0 equal to 54. And then when we were done, the first value would equal 54 and the second one would equal 4.56. So an array is just a series of boxes to hold pieces of data, like mailboxes in an apartment complex. And a person who lives in apartment 0 gets the first mailbox, and a person who lives in apartment 1 gets the second mailbox. And you can store anything in there that you want as long as it's of the correct type. So in Java, arrays are objects. As with all objects, arrays are created, instantiated with the new operator. That's why we have to do that. Variable name is equal to new, and you specify the type like int, and then inside the square braces, how many elements are in the array. So, for example, we declare our array called phone list, like that. That creates a reference to an array. We know it's a reference to an array and not just a variable because it's got those things there. And then we create, with the new keyword, we create an array and assign it to that reference. So the memory address where that array is stored is now stored in this reference. And quite often you do it at the same time, right? No reason to break them up unless you just really want to. One thing to note is that once you declare this array to be 10 elements long, that's it. You can't go and append an 11th item to it. It's fixed. Arrays are fixed in length. If you want a longer array, you have to create a brand new one and then copy all the values from the old one into the new one. Which if it's only 10 items, yeah, great. But what if it's 10,000 items? And then you want to add item 10,001 to it. Well, then you've got to copy all 10,000 items from the old array into the new one. So there are better solutions than using arrays if you need your data to be able to grow and shrink dynamically. But arrays are incredibly fast. They're the fastest, most memory efficient way of processing series of elements, storing them and processing them. And when I say most efficient, I could argue at other times, other ways. But since they're stored contiguously in memory, when the program needs to access them, it's very easy for it to find that element, right? If it's an array of ints, the first one is at memory address x. Well, the size of an int is 4 bytes. So the second element is going to be at x plus 4. And the third one's going to be at x plus 8. And the fourth one's going to be at x plus, right? Every 4 bytes is a new element. It's real easy for Java to figure out what address it's going to go to. It just does a little bit of multiplication and it's sitting there at the right piece of data. Whereas if it's another data type other than an array, there's something called an array list. Then in order to get to the next element, it has to hop around in memory in order to figure out where the new place is. They are implemented internally as a data structure that is a dynamic data structure, a tree or something like that, so that it can hook up, no, a linked list, and it has to iterate through it. And we'll talk about linked lists when we talk about arrays. So an array initializer, instead of using a new keyword in curly braces, you list the elements of the array. And again, once you create your array, this is now fixed, meaning it's a fixed length. We're not going to be able to then go in and add a 4th student to it. And we're not going to be able to go in and delete that student. What if we wanted to fake deleting it? Well, you could copy this value in manually there. And then you could 0 that one out, and now we've pretended to have deleted it, right? And what if we want to do that again? What if we want to so-called delete the first one? Well, we could copy this value here, right? And then we could 0 out that one. Now, what if we wanted to insert an item before there? What if Abe wants to be in front of Salam? Alrighty, well, you copy that one to replace this one, and then you overwrite that one with Abe, right? You see what's going on. And yes, you can do that, right? But again, what if it's 10,000 items long and you want to delete the first item? What are you going to do? You're going to copy 9,999 pieces of data, moving them up forward? Yeah, you would. So this would allocate an array of 3 string references. So they have default values. When you create an array, it gets populated with zeros, or 0.0s if it's an array of a floating point type, or false, because false and 0 are kind of the same thing, or if they are references, like strings, they all get set to null. Null is just a fancy word for 0. So when we, create an array full of floats, if we printed them out, we'd see a whole bunch of 0.0s, or at least that's what they are. And if we create an array of strings, then they would all be set to null. Really not liking talking about that yet, but we're going to have to hit that pretty soon. Arrays of references are different than arrays of primitive data types. Remember that primitive data types are your ints and your longs and your floats and your doubles. And they're real easy to understand. Arrays full of reference types are a little bit less easy to understand because we're dealing with objects. And to us, strings don't really seem like objects, but they are. They're objects, and they all have their own methods. You know, you can convert a string to uppercase and stuff like that. Let's play. Let's go ahead and launch NetBeans and create some arrays. I think we're on lecture S. QRS. Yep. Alrighty. Going to make an array. String, square brackets, that tells us that it's an array of strings and not just one string. Colors, equals, and then inside curly braces we're going to list some colors. Purple, red, and orange. What if we want to know how many elements are on it? Well, in Python we did that. In C++ there is no cool way to get the length of an array. However, this language gives us a method. Excuse me, it's not a method, is it? It's a property. We'll find out real soon. So what am I going to do? System.out.println length of array is, end quote, plus colors dot length. Whoops, put my semicolon in the wrong place. All right, so it's not a method because I didn't put parentheses after it. Right, that means it's a variable. But you can be sure that it's not a variable that we could change. If we call dot length and set dot length equal to 7, it's not going to grow the array. Heck, let's try that. Colors, this is going to be a syntax error. I'm probably going to delete it very soon. Yep, there we go. Cannot assign a value to final variable length. Right, once we create our array, it's of 3 items. If we want more, we're going to have to allocate a brand new array and copy all the old elements into it. Well, let's print it. Let's run it. Hopefully it'll say that there's 3. Yep, the length of array is 3. How's about we print them out? We're going to print them out. We need an index. Well, there's more than one way of printing an array. But the way that lends itself towards thinking about subscripts is to have an index counter that goes from 0 up to length minus 1. Why length minus 1? Because that's going to be item 0, that's going to be item 1, that's going to be item 2. We better stop there. If we try to get to item 3, it's going to go kablooey. Stop our program from running. Unlike C++, which will go ahead and load that value up, even though it's full of bad data.
Unlikely they do.
Yeah, Python does blow up if you try to read past the end of the array. Okay, so let's use a for loop. For parentheses, I'm going to use I since it's going to be an index counter. For int I is equal to 0, I is less than the length of the array. So colors.length, I++. And let's print out the element and its index number. So system.out.printf, parentheses, quote, colors subscript %d, because the index is an integer, in subscript, equals, let's get really fancy, backslash quote, %s, backslash quote, and when I say quote, I mean double quote, backslash n. Now that looks nasty, right? But we have to use the backslashes because otherwise it would treat this quote as part of the string. All right, and so we have 2 placeholders we want to fill in. That's going to be the index, and this is going to be the array at that index, at that subscript. So after the comma, I, comma, colors subscript I. Now normally when I print out elements, am I going to go to this backslash quote business? No, but it's going to make the output pretty for this one occasion. And what do I mean by pretty? Like that, right? I like that, just for this one occasion. So this makes it pretty clear. Element subscript 0 is purple, element subscript 1 is red, element subscript 2 is orange. And so if I say the first element, I mean element subscript 0. And when I say the second element, I mean subscript 1. You have to do that minus one thing in your head. All right, why don't we change one of the elements of the array. Let's say that I really don't like the color orange. I'm going to change that to something else. Silver. So colors subscript 2 equals, quote, silver. Now I could just copy and paste that list again. I'm going to use a different kind of loop. I'm going to use what's in C# known as a for each loop, and what C++ book calls a range-based loop. For, and I don't even remember what Python called it, for string s colon colors, in parentheses, open brace, system.out.println s. That's a short way of printing it, right? And it's not going to be all nicely formatted with index, counters and quotes and everything, but it'll prove the point. It's going to print out purple, red, and silver because we will have changed that element. Yep, and so now it says purple, red, and silver. There is a helper class for manipulating arrays and doing things with them. And I think it's just called array dot. Might be called arrays. I'm going to type it in. Arrays dot. Yeah, there's a whole bunch of them. A whole bunch of methods. This is a helper class that lets you make copies of arrays. There should be a sort function built in. So when we have an array of integers or longs or floats or something, we may call dot sort on it to sort those. I like that splitterator. I had never noticed that word. That's absurd. Okay. To string, we want to print our array. Well, that sounds fun. Let's try to print out our array using arrays.toString. Probably be even faster than that little for loop we wrote there. For parentheses, nope, no, I don't even need that. System.out.println parentheses arrays.toString parentheses, and we're going to pass in the name of our array, colors. All right, there we go. You printed it out. Now, the end user may not want to see their data presented between square braces separated by commas. But for our debugging purposes, arrays.toString is very handy. We don't have to write a for loop. On the other hand, did this take much typing? Especially if we deleted those guys, right? If we put it all in one line, don't necessarily do this, right? But did that take much typing? Looks like it's about the same amount of typing to me. Alrighty, now let's build another array that's going to contain the ASCII values for the characters in a string. So we're going to need a string. String name equals Joe Bob. We need to allocate an array of the same length. Well, heck, do I remember how to get the length of the string? I believe it's just called dot length. But I'm going to store it in a variable rather than write something that's extraordinarily complex. So I'm going to say int name length equals name dot length parentheses in parentheses semicolon. Why do I need that? Because I'm going to allocate an array of the same length so that each element is going to be of type int to hold the ASCII value of each letter in that string. If I'm going to make an array, what's the first thing I do? What's the syntax for it? What's my data type going to be? I just mentioned it. It's a string that we're pulling from, but we want the ASCII values, so they're going to be ints. So int, square brace, int, square brace. I'm going to call it name vals or something like that. Equals new, int, subscript, and I have to specify the name length. Name length in subscript. All right, before we do anything, let's just use this print statement because it's so easy to cut and paste. So copy that print statement, paste it here, but of course change the array name. That's not working. I apparently didn't really copy it. There, right. I just want to see what the default values are. So where it says arrays.toString, well, I don't care about the colors array anymore. I care about this name vals array. And it ought to all be zeros. There we go. So we're going to iterate through the name, pulling out the ASCII value of each character. And I hope I don't have to do this without looking up something. I'm going to push that down a couple, and I'm going to put my for loop above this. For I need a counter that goes from 0 to 1 less than name length. So I'm just going to use I again. For parentheses int I equals 0, I is less than name length. Semicolon I plus plus. Now in C++, getting a value out of a string is as easy as doing it out of an array. And the same is true for Python and C# and a great many other languages. So if I wanted to, don't type this because I'm going to have to fix it, I'd be able to do this. Int x is equal to name subscript I, right? And that would pull that character out. Well, can't do it that way in this language. Instead, what we're going to do, let's go ahead and get the value out. Int val is equal to name dot, and here's how you extract a character at a specific position in a string in Java. Char at with a capital A. C-H-A-R, capital A-T. Then you specify the index value, right? And so that's going to pull the first character and the second character and the third character and so on. But these are different types. This is a character. This is an int. I better do some casting. So parentheses, int in parentheses. Do I need to store it in a temporary variable? No, I could have done all of what I'm about to do in one line. But then on my next name vals subscript I is equal to val. Now I'm real tempted to get rid of the use of the temporary variable so that it was just one line of code in the for loop. You know, I'm going to do it. I'm going to take this code from here to here, cut it, put that there, and delete that. I don't think that makes it too cryptic. I think maybe that makes it easier to understand. All right, and there's the ASCII values of my string. 74, 111, 101, 32. I could look it up, but I know that a 32 is a space. And I know that capital A is 65. So if I went up here and I made this say Abe Bob, then or like all caps there, I'm going to know that that's 65 and 66.
The arrays here is underlined.
On yours or mine?
Mine.
Oh, okay, I'll come look. So when I run it now, since I changed the name, 65 is an ASCII A, 66 is an ASCII B, and so on. Tell me what the import is. Scroll up to the top. Oh, well, see there, right it is. For some reason on mine, added the import already. But Daniel, you need to go up there and add that.
Okay, now it's working.
Good.
Console sentence. Console
I went and changed it to Abe,
Oh,
just to illustrate
Okay.
65, 66. Okay. So say we want to create another array that has those same values for whatever purpose. We want to create a second array that's a spitting image, a duplicate of the first array. Now you could cheat. There's a function called arrays dot copy of. We're not going to cheat. We're going to use a for loop. To make a copy of array, you got to do a few things. Allocate new array of same length as the old one, and then use a loop to copy each element from old to new. Okay. So, I want this array just to have an exact duplicate of these values in name vals. So, I even have the length of it stored right here already. But I think I'm going to do it just a little bit more generically. So it's going to be int parentheses, int subscript and subscript new array equals new int subscript, but in here I need to specify the length of the array that I'm copying from. So I'm going to do name vals dot length, right? Why am I doing that rather than just using this variable here? Because if you copy this code and paste this somewhere or whatever, this is a good way to do it, right? Then you're absolutely guaranteed at this point that these two arrays are of the same type. And now we need a for loop to copy the values in. It's going to look a lot like this one. It's going to be a for int I equals 0. For int I equals 0, I is less than name vals dot length I plus plus, and we're going to say new array subscript I is equal to name vals subscript I. And I'm getting these little warnings out the wazoo over here. Oh, the array is only written to, never read from. Yeah, whatever. Manual array copy. This is cute. NetBeans is so helpful. It sees this code and it recognizes it as being an array copy, and so it wants me to replace it. Bleh. I'm going to undo that. All right, there we go. Let's sort that. The arrays class, the helper class, comes with a sort method to make things easy. So, arrays.sort, parentheses, and we're going to pass in new array. I don't know why that's got a red box around it. And let's print that out. System.out.println arrays.toString parentheses new array in parentheses semicolon. All right, and there it is sorted. That's our source array. This is our copy of it.
Can you go back to your code?
Yeah, I absolutely can. How far do you need me to scroll back? Oops.
Just right there.
There we go.
Too fast.
Yeah. What would be kind of nice is if we get tired of writing these loops for printing them out, is to make a method that does that for us. Like if I go down here, I don't know how many more arrays we're going to print out, but public static void print array, and it's going to be an array of ints because that's what we've been printing. So int subscript in subscript IA or AR for array, something like that. And then just copy this line for ease of, paste it and replace new array with AR. And now every time we want to print an array, we can just call print array followed by the array. Then later on, if we want the array to be printed out, like we did at the very beginning, with more, special effects showing all the indexes and stuff like that, we could modify it to be a for loop down here. All right, and that worked. I'm not going to go back and replace all my other system.out.print lines with that, but for any future arrays of ints that I print out, I could do that. What if I want to print out an array of strings? Well, I would need to overload this method. So I'm going to copy that. I'm going to paste it and just change int to capital string like that. And I don't think I even have to make any other changes. Now we've got two methods. One that handles arrays of ints and the other that handles arrays of strings. If we wanted to, we could genericize this so that it would take an array of anything and print it out. But we're certainly not there yet.
Well, do you know when you get there?
That's more like a Java 2 thing, but I could throw it in. I'm just not going to throw it in this lecture. I bet since we have an arrays.sort, I bet that there's an arrays.reverse that would put the 111 at the end and the 32 at the beginning. Let's play with that. I bet there's one. Arrays dot, nope. Sort. Nope, we've seen sort. Splitterator. Alrighty.
Terminator is a splitter.
Yeah. Arrays, reverse, Java. How do I reverse an int array in Java? Okay, you can do it yourself, right? You can create a temporary variable, store in the first one, the last one, and then, right, and you could keep doing that until you got into the middle. But forget it. All right, what if we wanted to search the array? What if I want to know if there's a space in my array? Well, there are functions for doing that. There's arrays.search, right, and we can find it. When I started typing that, it popped up the words binary search. There are two kinds of searches when you're dealing with lists. There's a linear search, where you just begin at the beginning and you keep going. Like if you're searching for somebody in an apartment complex, you went to the first apartment, you went to the second one, you went to the third one, eventually you'd find them. There's a more efficient one, but it only works if the data is sorted. That's called a binary search. Like, what if everybody in the apartment complex was sorted by their last name, right? And so, the Zacharias live, at the very last apartment, and the Abrahams live in the first apartment. Well, if it's sorted like that, you go to the middle. Say you're looking for Miller. You go, okay, Mr. Miller live here? No. Well, then you jump halfway up here. Mr. Miller? No. And then you keep zeroing in on it, just like those guessing games. I'm thinking of a number between 1 and 100, and I'm thinking 32, but you don't know that. So you guess 50, and I say lower. So then you go between 50 and 100. 25, and I say higher. And so now you think between 25 and 37, or between 25 and 49, and you guess like 37. And I say, nope, lower. And so then you go between 36 and 26, and you zero in on it. It's called a binary search because you keep chopping it in half each time. And it's far more efficient than a linear search. Why? Because if a linear search is searching a list of 100 items, then if the data doesn't exist in it, it's going to have to search all 100 of them. And on average, it's going to have to search 50 of them, right? Because, if it can be anywhere and you did 100 searches 100 times, the average of all these things, 100 would be 50. An average of 50 searches in order to find your data. But if you implement the same thing as a binary search, it really would only take 7 attempts. Just like if you're guessing a number between 1 and 100 and you use that algorithm exactly, 50, 75, and you keep cutting it in half. There's a way to mathematically calculate the maximum number of searches it would take to find it. So 7 maximum, as opposed to 100 to rule out that it's there. You can see that it's a huge savings, which just gets astronomically better. Like if it's 1,000 items long, I think it only takes like 10 or 11 if you're doing a binary search, and it would take 1,000 to rule it out. Anyways, that's what binary search is, but for binary search to work, it has to be sorted. That's why they give us a sort method. Anyways, we're not going to rely on, we are tough guys and girls. We're going to write our own loop to find out if a number is in our list. So I'm going to say int target is equal to 32, just to remind myself that that's what I'm looking for. And I'm going to create another variable called foundAt. And if we do find it, then foundAt is going to be set equal to the index where it's at, right? So if it's at position, the first position, foundAt's going to equal 0. If it's at the 10th position, foundAt's going to be 9. If it's not found, it's going to be -1 to indicate that it wasn't there. So int foundAt equals -1. And now we just need a loop. It's going to be yet another for int I loop. For parentheses int I equals 0, semicolon, I is less than the length of our array, so I is less than new array dot length, semicolon, I plus plus. And now let's check. If the value at that position is equal to our target, we're going to set the foundAt. So if parentheses target equals new array subscript I, bingo, we found it. Let's set inside the curly braces. I think I have too many closing curly braces now. Let's set foundAt equal to I, our index, and then let's break. Why break? So that we don't just keep searching, right? As soon as you find it, we're done. What if the array is 20,000 elements and you find it at position 2? You don't want to keep looking through the other 19,000 elements. So by the time we get here, if foundAt equals -1, we didn't find, or that item is not in the array. That element is not in the array. So we could write some kind of if statement. If foundAt is less than 0, why not just set it equal to -1? I don't know. FoundAt less than 0, let's print a message. System.out.println. Let's do printf so that we can actually print what we were looking for. Printf, parentheses quote, placeholder, so %d, not found in array, \n, end quote, comma, target, semicolon. Else, we're going to print where we found it. So else And because I'm lazy, I'm just going to copy that system.out.printf. Else printf %d found at index %d. And the first placeholder gets target, and the second one gets found at. You've probably gotten the idea that you use loops an awful lot when handling arrays. Right? They go hand in hand. We should have started talking about arrays the next chapter after we talked about loops. Instead, they talked about strings. Arrays are more important than strings, honestly, in terms of computer science. For understanding, right? Alrighty, so it sorted our thing, it did a search. Well, we did our search, right? And we found it at that position. Now, what if we look for a number that doesn't exist? I'm going to change target equal to something that I know doesn't exist, like 5. Can't quite get it all on one page, can I? Unless I remove a comma. There. All right. If I run it now, it stepped through the array looking at every element. It didn't find it because found out what remained -1 once the loop was done. Now the search method and the binary search method of the arrays class do very similar things. Whoops. So if I did this, found at equals arrays dot binary search, arrays dot binary search, parentheses, and I pass in the array name, new array, and then I pass in my target. That would just be more efficient. We wrote a linear search because it's a loop. It started at 0 and then went to the end of the array. Now let's find out what binary search returns. It's going to return a position, but what if it doesn't find it? That's what I'm worried about. It might not equal -1. Maybe they made it do something else. Whoops, where'd that come from? Alrighty, right click, show Java doc. What does it return? It returns the index key if it is contained in the array. Otherwise, it returns minus insertion point -1. Well, what in the world does that mean? Let's change our target to like 64. And I'm going to cut these two print statements here and paste them after the binary search. No, it's easier to move the binary search. I'm going to move this up here. I'm going to set my target equal to 64. Well, let's do 65 just to make sure it works, right? First time I run it, it did find it. 65 is at index 1. Now I'm going to look for 64, which doesn't exist. But I better print that value out, right? Because otherwise I'm not going to know what failure code it returned. So temporarily I'm going to comment out these lines, right? Just because I want to see what found at returns as if it doesn't find it. All right, I'm going to run it. Oh, I left it at 65, so it's going to still have found it. All right, I'm going to change it to 64, which doesn't exist in our array. It does return a negative value, but it returned -2, meaning that if it was going to insert it, it got to that place before it decided it wasn't there, right? So if we looked for a value that was less than 32, like if I change my target to 31, and I run it, It had to search and search and search until it got to that position, -1.
Try 112.
Yeah. So if we try 112, it's going to have to search all the way to that point. So at 8. 0, 1, 2, 3, 4, 5, 6, well, you know. It's indicating where that value would be inserted. And it said something about -1, and so maybe, you know, it would have been at the 7th position, you know, 1, 2, 3, 4, 5, 6, so it would have been there, 7. Anyways, you get the idea. That's why I did that less than 0 business rather than equal -1. Because a normal search function will just return -1 if it doesn't find it. But a binary search can tell you where it would need to be inserted for it to be there. Now, I don't know how useful that information is, but they give us the ability to do that. Now I'm going to uncomment this stuff out. So let's make some comments here. To allocate an array, I'm going to make a multi-line comment. To allocate an array, its data type, subscript, array name, equals new data type, and then followed by the length, right? X, where X is the length, the number of elements. You can allocate an array and initialize it with values at the same time. Data type, array name equals, and then inside curly braces you list values like value 1, value 2, value 3, and so on. Or if we prefer, we could call them value 0, value 1, value 2, right? Just to keep in mind there. To print an array, use a loop. We've shown 3 different ways. I'm going to just mention the first way. It's been a while. For int I is equal to 0, I is less than array name dot length, I plus plus, and then print a name subscript I. It's one way to do it. Or there's the for each. So for data type, V for value, colon, array name, print that value. Clearly this is a shorter syntax. And the cheap, easy, cheaty way, print arrays dot toString, passing in the array name. And I hope it's not going to confuse you that I use data type, right? That's just like int or string or float or whatever. I could go back in and I could change data type equal, you know, to int all the way through my examples. I'm going to put a little comment. Cheater. I want you to know how to print it with a loop. So please commit that to memory. To copy an array. Step 1, allocate a new array of the same length. Step 2, use a loop to copy each element from the old to the new. To sort. Arrays.sort. Parentheses a name. I'm not real happy with a name. I may do a search and replace and just call that array. Search and replace, I just did Control H. Replace all. I like that better in my notes. To search, use a loop, or use arrays dot search, or use arrays dot binary search. Binary search is the most efficient, but requires the array to be sorted. And what's the big deal about that? Well, you know, if you're going to read in 10,000 pieces of data and then never add any more to it, if you're going to construct your array before you start searching it, great, go ahead and sort it, because that makes the searches that much faster. But if you're going to be doing a whole bunch of searches into it at the same time that you're building it, that would require you to sort it every time you add a new piece of data. And if it's a short array, then that doesn't matter much. But if it's a long array, you know, the sorting does take time. If it's 10,000 elements long, it takes, you know, a while to sort it. So maintaining it in sorted order is expensive, processing-wise. So if you're going to do more searches than insertions or appending to the array, great. Go ahead and sort it. But if you're going to do more insertions than you do searches, don't. Now you could read the array into a file, sort it, write it back out. You'll be good to go, right? So then that when you want to do some searches on it, you can read it in and, you know, and do searches. That's pretty much the idea behind databases, except they create indexes, right? They don't actually change the order of the elements in the database. What if you have a database full of, you know, every person in Oklahoma, all, you know, however many millions of us there are in it? When you do a sort by last name, it's not going to go and rewrite every, you know, all those millions. Instead, it's going to update update an index file so that the original data is preserved. Anybody need eyeballs on your screen? I haven't asked in a while. You doing okay too, or you need help? Okay, I'll come look.
Could you?
So going back to our notes, the search functions return a value less than 0 if the value is not found. All right, since we know how to copy arrays, what if we want to change the values of our array? Like, what if we want to add 1 to every element in our array? We could do that. Oh, do you need help? No. Oh, okay. So for parentheses int I is equal to 0, we're just going to iterate through the loop again. I is less than new array dot length, I plus plus. And then new array at position I is equal to new array position I plus 1. Now there's a shorter syntax. We could have just done plus plus. But anyways, there we go. Now let's print our array again. Print array, new array. Let me guess, I used a capital A. Yep. How do I get rid of my search bar here? All right, and so it changed from 32, 65, 66 to 33, 66, 67, and so on. We added 1 to every element in the array. So I think now that you've seen so many for loops, you're getting the idea. We're traversing the array by its index. We're printing it out, or we're doing a comparison. We're doing an if statement, or we're making some modification. What if we want to add all the numbers in the array? It's going to be the same syntax. We can even just copy that for loop pretty much. So let's declare a variable to hold our total. I'm fond, even if it's an array of ints, of storing the result in a double so that if later on we calculate the average and stuff like that, it's already of the right type. So double total equals 0. And then let's write our good old for loop yet again, but I'm tired of typing it, so I'm just going to copy it. Copy my for loop header, paste it, And then the line in here is going to be total plus equals new array subscript I. And what's the average going to be? It's going to be the total divided by the length of the array. So double average is equal to total divided by, what's the length of the array? New array dot length. And I didn't print them out, right? Great. System.out.printf, quote, total equals %f, comma, average equals %f, \n, end quote, comma, total, comma, average. Fair? I assume that's correct. What if I wanted to display it rounded to only 3 places after the decimal point? What do I change my %fs?
0.3.
Yeah, let's do 0.3f. Much better. Alrighty, I think we're just about at the point where I want to stop. I'm going to go back to the PowerPoint. Yeah, that's definitely a good place to stop. So homework over arrays. Homework 16. So, surprisingly, this assignment focuses on arrays. Write a program that asks the user how many elements there should be in the array. So they can just say 3, they can say 3 million. The program allocates the array. It fills the array with random numbers between 1 and 10. Prints the array. I should say with a loop, because I want you to write your own. I don't want you just to use arrays.toString. Allocates a second array of the same length. Copies, using a loop, the square of each element from the first array. I don't know if the word copies makes sense when we're changing it. So how about just saying copy, using a loop, the first array into a second array, into the second array. And then we'll say loop through the second array, squaring each value, each element. That makes sense, guys? It's so shockingly similar to what we did today. But I'd like for you to, go ahead and rewrite it rather than just doing a big copy paste and then trying to figure out, what goes where. But your notes, right, from what we did today, the daily notes, pretty much are going to show you how to do just about all this. What's the only thing we didn't do is random numbers, but you know how to generate random numbers. We've done that a couple times, I believe.
Random times.
Yep. All right, let's make a Dropbox.
There's a homework 15 there, but did you assign that one?
Maybe I never assigned it.
Desert classes? Dessert classes?
I thought I did, but maybe I never made a Dropbox for it.
So
You're right. Okay, so Y'all could have been slaving away on that for the past couple of weeks, but let's go take a look. I really thought I'd mention this. Let's go look at it again. I'm sure I did, and I'm sure I just didn't make the Dropbox for it.
Oh, we can. Yeah.
So, we're going to make a candy class, an ice cream class, and a cookie class. And so I'm going to have to give you extra time on the array assignment just because you're also going to be doing this one. You have complete freedom to design your classes how you like. Should be an S there, huh? So the functionality. We're going to ask what kind of candy they like, how many pounds they want, what's the price per pound, what kind of ice cream they like, how many gallons they want, what's the price per gallon, and what kind of cookies they want, how many cookies they want, what's the price per dozen, and then it prints out an order. That many M&Ms cost that much ice cream costs that much chocolate chip costs that, the subtotal plus add sales tax. Now I just say assume a sales tax of 10%. Alrighty. Hope that makes sense. The trick to this one is to notice that it's not all the same exact thing, right? Candy has a pounds and a price per pound. Ice cream has a gallons and a price per gallon. Kind of the same thing. And this one has a number of cookies and a price per dozen. I really don't care how you implement it as long as you implement it. I would prefer for you to make 3 classes rather than just 1 class. I don't know how you would do it with just 1 class. But you don't have to ask the user, you know.
Is there a function that with it, like, so these are so variable candies are this, variable ice cream is that, and variable cookies are this? Would you, if I were selecting on such a list, or would I?
If we were at the point where we had already talked about arrays of objects or lists of objects, then yeah, we'd want to be able to do that. But that's a bit more advanced object-oriented programming than we're ready for yet. But there's a keyword which will tell you what kind of class you're looking at, so that you could tell if you're looking at a candy or cookie or ice cream object. Alrighty, Dropbox, while I'm thinking about it. And then 2 more Dropboxes. What am I doing? You're going, I don't know. I'm thinking about the homework that I'm going to make. So the dessert, the ice cream and stuff like that's going to be due a week from today. And then the arrays is going to be due, the following week. Right. Give you a little bit of, give you the weekend, the extra weekend to work on it. And y'all are naughty. I know that somebody knew there was another homework assignment out there that I hadn't made a Dropbox for, and you just didn't want to work.